Hi guys, this is Pravin Kedia from IBM. We are here to talk about the IBM data governance tools on Cloud Pack for Data on WKC platform. Welcome to this session. I am Pravin Kedia. I work for Expert Labs at IBM and I am a CTO for Expert Labs. Today we are going to talk about WKC on governance using the IBM tool. Here is the agenda for the session. Today we'll talk about Cloud Pack for Data architecture, then we'll talk about Cloud Pack for Data governance and WKC and data gaps, DataOps, and then also going to talk about case study where we implemented these for a North America customer. So today we'll talk about data governance and data quality for Cloud Pack for Data using WKC. Um, here is the architecture for the Cloud Pack for Data. Um, Cloud Pack for Data is the IBM platform which helps customers gain insights. It has the overall feature of collect, organize, analyze, and infuse. And it's a platform on which IBM products are available either as the base product or extensions. Um, Collect is the area which is responsible for ingestion, storage, access, and that is where all our databases, data virtualization, master data connect, event store, DB2 warehouse, all these are part of that. Organize is where the data governance is implemented. The IBM data governance platform is on WKC, and that is the governing layer across all the products that is there on the platform. Then we have Analyze, where we have the notebooks, we have the Watson Studio, Watson Machine Learning to do the exploration and analytics machine learning. And then we have Infuse, where we can actually gather the insights from the data that is there on the platform. So today we are going to talk mainly on the WKC part of it, the governance on the platform, and that is the strength of the IBM platform. And the product behind this DataOps strategy is Watson Knowledge Catalog. So we talk about Watson Knowledge Catalog. It's a one integrated solution that delivers trusted data to enterprise. The enterprise can do the enterprise data integration, governance, data quality, and then data consumption. So we talk about three different personas on this platform related with the governance, which is the data engineering profile or the data governance teams or data citizens. So data engineers are the ones who build the data integration, extraction, ingestion, monitoring. Data governance teams is the main focus of this talk today, where we talk about building data glossaries, managing reference data, identifying data stewards, governing the assets with workflows, discovering metadata, classification of assets, data lineage, profiling of data, applying validation rules, and data quality. So we talk about the case study today on data quality. And then we also have the data citizens for the consumption from these governance based on their role, based on their schema. They can actually consume data from these as a self-service to find and find the relevant data, comment and share and rate the data that they have seen, prepare the data using data refinery or data storage tools on this platform, right? So basically, to sum it up, Watson Knowledge Catalog is an end-to-end data integration, governance, quality, consumption platform, which can deliver business-ready solutions for the end customers. So then now let's see how we can use the data governance platform for data fabric and privacy. So WKC is the gel or the binding that can be bind the layer across data enterprise. So on the left side, you see different databases which are there either on premise or on cloud or anywhere, and how that can be brought into this platform so that governance can happen as a single self-service on this platform using the WKC orchestration and lifecycle management. So we talk about smart integration, augmented knowledge based on governance, and then self-service for consumption. So there is a single policy for security and compliance that is provided by the data governance tool WKC on this platform. We talk about WKC, how it helps deliver this single experience. So data governance is basically to set up the foundation layer for governance. So any user on top of WKC will always see the data as the governed platform, and then organization will need to comply with the regulatory requirements, share their business definitions, concepts, communication, and enforce policy. So definitely whatever policy you apply at this layer will apply to all the components on the Cloud Pak for Data platform. So people don't have to change the policy or worry about the trusting your data. The second major thing that can be provided on this platform is the data quality rules. So we can actually deliver the quality of the rules, understand the structure of data, study the data profiling using the automatic profiling feature on this, and then automatic discovery, delivering the reliable and timely data to the enterprise. On the other side, data citizens or the scientists or business analysts can consume data from this layer without understanding the integrity of it. And data privacy is maintained based on the what policy that organization has put forward on this platform. So our vision, or IBM vision on merging the data governance, quality, and cataloging is doing an automation with efficiency and operation in making the data useful and business ready. So if you see that platform provides automated metadata services. So we have something like auto discovery of data, auto classification of data, auto detection of sensitive data. So you can define the policies. Based on the policies, what is sensitive data will be auto detected by the platform. Also has the automatic analysis of data quality on this. We have 9 different quality parameters which are used for analyzing the data on this platform. And then we also have help people do the auto business term assignment based on the policy that. On the self-service interaction, people can search and find the relevant data, tag the data, comment on the data, review the data, have a workflow and collaboration built on this platform. And then this platform also has data reference and data preparation facility. And we also provide end-to-end data lineage on this platform based on the governance rules and policies that can be enforced. And also we have reference data management, business glossary management, auto data classification, model building, bias without bias, knowledge accelerators, and auto data discovery. And all these are powered by the machine learning and automation tool that is automatically working in the background to help customers understand. So now let's understand how automating a knowledge catalog can help people in doing the governance on this platform. On the right side, you see the categories where you have the governance artifacts and collaborations. Then we have the default catalog, which is where all the assets are there defined, and then collaborations can access those assets on the default catalog. Then there can be private catalogs created, and then we can create data quality projects where we can run the data quality analysis. That's what we are going to see in the case study that we did for one of the US customers. And then we have to create an analytics project to do the analytics on them. And then we can also share the information assets with the other thing. So what makes this platform useful is basically the auto discovery of data within the data sources, auto classification of structured and unstructured data. So whatever data sources that we have, whether the data is in a database or whether it's on a file system or it's on Hadoop using the IBM data virtualization, we can do that analysis. We can also do auto term assignments to put data in context Also, we can do profiling of assets for statistics about data. We can also auto-generate the data lineage mapping through code analysis to the policy enforcement to help customers do the compliance and then recommendation for data to use in the project. So these are some of the features that are supported on the platform. IBM data governance, we talk about these 8 simple steps in implementing a data fabric. We talk about the technical metadata where we automatically gather metadata, make it available in the data catalog. And then this is where the auto discovery comes into picture. Import or define business terms in a glossary is business metadata. That is where we can actually define the organization specific terms in the glossary and automatically match business terms to physical data items that are available on the platform. Then we talk about master data management and data quality analysis on this platform. So that is where MDM solution and the data quality solution comes into picture, which where we discover and manage the reference data sets, define and build the master data set, generate data quality metrics for all source and target data. Then we talk about operational metadata. That is where we talk about collecting and usage of metadata for query analysis, statistical analysis, data lineage. And then we talk about active metadata management, initiating a knowledge graph, running the machine learning models over the graph to activate the metadata. And this is where the IBM core strength comes into picture. And then we talk about data virtualization, which is a layer where you can actually augment the semantics for analysis across the system without actually bringing the data onto the platform. And then it works with our machine learning models to actually accelerate the data virtualized view for the governance. So data may be still in the source database, but we will create a virtual layer which will be governed by this platform. Then we talk about the integration and the orchestration layer where we can automatically build, optimize, auto integrate the data delivery services. The data stage comes into picture over here. And then we talk about the complete data fabric where we create the registry of all the components that are required to run the data fabric. So these are the 8 simple steps. So now we are going to talk about the WKC reference architecture on Cloud Pak for data. So here we see on the left side data sources where the data can be coming from different databases, relational database, system of records, system of engagements, data sources. That could be SAP systems, could be any OLTP systems, or can be any data warehouse systems. Um, then we talk about the application data. Application data could be like customer data, supply chain data, any other data. And then other data types could be video, audio, open source, third party, social media governance, right? And then on the target, we see the knowledge zone where the catalog comes into picture, data governance catalog comes into picture, which provides business glossary, policy management, reference data management, data lineage, workflow, automated workflow. And then we also have something called common MDM reference data governance layer, where people provide 360-degree view of the governance data on product, customer, master, and transactions. And then we also see the important layer on data quality, where we define the data discovery, data profiling, automated data classifications, quality issues detection. We have a dashboard, quality dashboard, where we can see the quality profiling data. And then data consumption, where it is actually enforced, the policy is enforced in the data consumption layer. People can do self-service on this platform, and then they can actually do the data preparation. And then on the right side, we see the data profiling done by different consumer layers. That could be the Cognos, could be the any BI reporting applications, could be any other tools. So when we talk about data governance using WKC, we call it as the test data management, where data governance can be enforced on the test data, so that it can be shared with different users. Data can be masked, right? Where the sensitive data could be masked. The other thing could be master data management, which can provide governance for the MDM across the data sources. And then we can also have the data and AI in the industry accelerators. We have a lot of industry accelerators built by IBM, provided to the customers to use the inbuilt models. Then we also provide the data science on the consumption side, where it's a governed data platform for self-service. We also have the analytics tools, and then advanced data privacy, data protection rules, and masking rules are applied automatically based on the policies that you define on the platform. So let's look at the second part of this presentation on how we implemented data quality rules on SAP vendor tax management data for one of the utility companies. So we had the following like agenda for this. Like this is like some initial groundwork we did with the IT team on the Snowflake's database that they were using. And what we did in that is identify and study the tables required for this matching use case, and then clarification analysis of conditions, and then joining the data from different sources in the source Snowflake database itself to create base tables for this analysis, data quality analysis. And then we actually implement the data tax ID matching use case on this platform. We'll just show you how we did that and then demo on it, and how did we create the data definition rules on the platform, and how did we create the data quality rule on the platform to implement these and to find the matching data which customer wanted to find on this platform. So let's look at the customer requirement. There was a customer table, address number, and then there is a address and the vendor names, right? So the thing is, we wanted to first harmonize the vendor names. Like the names have to be upper names, uppercase, and any name cannot be longer than 35 characters. So these are some of the data quality rules that customer is given. And if the name is either in name 1, name 2, name 3, name 4, they should be matched together. And if program will look at any one place in the name, we can get a false positive. So first we got a requirement from the customer that anywhere like corporation is maintained, we should say corp dot should be corp, limited liability corporation should become LLC. So this is some of the tools that we want to use for standardization of data. And we created a data definition rule. So before we create any analysis, we have to create a data definition rule. And the rule was very simple, where X not X uppercase or length greater than 35, or it contains these terms, right? So we want to highlight the terms which are not matching the data quality rules and highlight them, flag them for analysis. So this is a very simple rule that we created. The same rule, this rule got auto-generated based on the drag and drop functionality from the data definition rule editor that we have for the customer. Once we implemented the data quality rule, we have to assign the variables. So variable here, X variable is basically the name 1, and the Y variable is the name 2 from the 2 different tables in the source. And then we actually match these rules so that we highlight the things which are not satisfying these rules. And this was a very simple use case on data quality that we implemented for the customer. Then let's see how we implemented a second rule, which was little bit more complex on say, vendor management. So these are the SAP fields, KTOC and all that, AUDT, BUD. So we wanted to first, based on the customer requirement, they wanted to implement the data quality matching across 3 different SAP systems. They had the SAP E03, C11, and then SHP And the same code for the vendor was different in 3 different systems. So we have to match this code across these 3 systems. And then second was we wanted to actually take the data only greater than like 1st July 2020 across these 3 systems. And then we wanted to match the field in the 3 different in the 3 different databases where VAT tax number 1 and tax number 2, and that those 3 fields could be having different values in 3 different systems. And then we also need to match, do the secondary check on the name and the address. So we want to see if the same vendor has 3 different addresses or different names in 3 different systems. And then we want to highlight those names in the output. So this is a way, another simple matching. So again, we did some groundwork in the Snowflakes table, created some base tables to remove only the required 24 columns. And then also we created a view to remove the data which is greater than which is less than 1st July. And then we also did outer join based on the 3 values in the target table as per the requirement. And then we created a SQL virtual table in CloudPack for data quality project so that we can only see the required data which is not null and then which is not 0 or not 1, right? So we are removing the unnecessary data using the SQL virtual table in the CloudPack for data. We could also do the create virtual table in CP4D itself directly with all the tables join in a single query to remove the unwanted data, right? So both this system works, but preferable is this first way because this will reduce the amount of data that needs to be joined together so that CP4D performs better. Then we went ahead and created a data definition rule where we said the tax ID exists in the first system, tax ID exists in the second system, and then if they are matching, then we check whether the name exists, and if name exists, whether the name is same or not same. So this is a simple rule. So this will highlight the data where the tax ID matches, but name is different. And then we ran and associated those with the different source tables, name column and the tax ID column, name column in the tax ID column, and created the output as a table on the platform. So that was the secondary requirement that we did with the data quality for this customer. Then we implemented another set of quality rules for material management. The first one was for like tax vendor matching and highlighting the blacklist, whitelist for the vendors who's not matching across the 3 systems. Here we're talking about material management. Again, we had the similar procedure. We work with the backend team to identify the tables required for that, how to do the joins in the Snowflakes to create base tables, how to create the tables, virtual tables in DB2, and then use in the CloudPack for data WKC platform, and then how to use the mapping. So material management in C11 and material DVA management in E03, where 2 different fields, MARKL and Sparta, and they have to be mapped with the material master to provide the required data. So let's talk about the requirement 1, where we had to compare the GPP material master. So we need to connect to the material table in the 3 different systems, list all the material numbers that are in any of the 3 ERP systems, add columns with the first 16 digit for each item, and then check if all the 3 workspace items are same or not. So again, we are seeing that vendor name, first 16 digit of the vendor work item is same or not in the 3 systems. The second requirement here was to list all material numbers that are in any of the 3 ERP systems and then highlight those which are not matching the brand value. So here again, we went about creating the SQL virtual tables in Cloud Pak for Data. So we created the virtual table and took only the first 18 characters. So we did not change the data in the source database, but we created a virtual table in Cloud Pak for Data. Then we actually applied a simple rule where the material number matches from the first two systems and the 16-digit matches on the system. So so we are highlighting all the rows where the matching record is possible, and then we use the thing to calculate the records and highlight the records that are matching across the systems. So this was another simple use case. And then we could do a join based on the material number and then highlight the fields, matching records, and put to the output table that can be saved to the target. So simple output table had the material number from and the work item number from the first table, second table, and then rule met or not. And then we can run this analysis to find the materials which are like not matching. Second use case, let's talk about it on the brand comparison value, right? So we had a table where the brand names in the first system C11 and the second system E03 were two different things. Like in the source, the numbers are different, and on the other database, numbers are different. But if you see the description are same. So we again created the same base tables, taking the first 16 digits of those numbers and created the virtual tables in Cloud Pak for Data. Then we created a rule. Again, we saw that if the two numbers exist and they are same, then we actually add the material and the Sparta in the reference column. So we are doing the reference column lookup by this policy. So we are doing the reference lookup by this policy, and we are trying to highlight the ones which are like mapping the same material number differently in the different table systems. Again, we run the data rule with different columns, so inputs, and then our output, we are again doing the matching, and then we are also having the output whether the rules met or rules are not met. So that kind of output in the output system. So these are some of the use cases that we created for the end customers on the US utility company using the data quality, and then this helped them to do this rule set creation on their own for their own requirement. So these rules and all those were created by the customers themselves, the business teams themselves. Once we went through this process, and they can do these things on their own now. So thank you for listening to this presentation. Have a good rest of your evening. And if you have any questions, please let us know. Thank you.